Hello, and thank you for taking time to watch this short video. So the purpose is to give a short taste of what my new clustering method that I have called Spinal Gator can do for us. And I'm going to make an example where we look at longitudinal data. So I've been watching or visiting Cytobank and downloaded an experiment, and exactly what the experiment is, I don't know, but it consists of a number, I don't know, 25 or 26 FCS files from different time points and with different treatments. And the paper in question, I can just flash it here so you can go and find it yourself. And here it's flashed again. So, yeah, here you see the paper. I'm not going to recite what is written there. So, I start a Jupyter Notebook. I enable Matplotlib with widgets. I import my methods. And then I construct an object of the class that I call Spinal Gator. And for that, I need to specify the path to the files that I've downloaded, to the path to the FCS files I want to study. And I might need to specify which channel, the names that I want to use is given in. And then for some strange reason, the FCS files I have downloaded, they don't conform quite to standards, so I need to ignore some errors in them. So the first thing I do is I take a look at what are the channels, what is the data in the FCS files. And I'm an amateur, I'm not a biologist, so what I recognize is some CD markers, I recognize DNA, and the rest of the markers I'm going to ignore. So they're very important. If I go and look in the paper, I see they're essential, but I don't know about them, so I'm going to ignore them. So I have a magic timing command here, just to make you see how long it takes to load in these FCS files. So what I'm doing now, I'm taking a sample of 10,000 events from each of the FCS files that I downloaded. And there are some error warnings here, and that's because there are some errors in the FCS file. If you have clean modern FCS files, you will have no problem. So this took me 22 seconds. Then I go on and specify that it's the CD and the DNA markers I want to use for the clustering. The next thing I do is I initialize my Gator object for interactive user-guided clustering. So what I'm doing is I'm organizing the events, putting them in an order so that similar events are next to each other. So that I'm going to demonstrate that makes it somewhat easy without having any clustering to see where are certain chunks of cells of certain types. And now I'm ready to start clustering. So this took a little longer than the time it took to read in a sample from each file. So it's only 10,000 cells from each file, so it's, I don't know how much. Let me try to see. So I can see how many cells I have. I have 260,000 events, self-events. So there are 26 files. And now if I click Heat Map tab, I see that I have organized my events so that the CD8 positive, they stand out very much. So do the CD3 and CD4 positive. So already here before declaring any clusters, I see structure in this dataset. I see this is a meaningful dataset, even though I have not normalized or anything. I just took the raw data, no cleanup. I see structure. So now, what does this widget say? It says cluster ID. So that's the cluster that I can split up, subdivide. Then there's the minimum cardinality. So I split it up into two pieces, and here I specify how small do I admit the smallest piece to be, or the minimum size of any of these two pieces. If I cannot split up in pieces of that are minimum that big, I'm not going to split up at all. So let's see how big are the clusters here. Let's say we want to get hold on the CD8 at least. So that's something like 50, so that's, I don't know, 10,000. And then I simply say split cluster. And I get two clusters. Then I can say I want to split cluster 1 or cluster 2 here. I said I was interested in the CD8. Actually, what I'm interested in is in the CD4, because the paper says CD4 is special. So I'm looking at this part with the T cells. That's cluster 1. I have already the T cells in cluster 1 and B cells and other things, neutrophils, in cluster 2. I drill into cluster 1 and ignore everything about cluster 2 because I know it's the CD4 positive events, cells that I'm after. And so it's the CD4, so now CD4, that's in cluster number 4. And I even know that it's the CD86 that I'm interested in. But now when I'm standing here, it's a little bit, so I'm wasting a lot of space on displaying cluster 2 that I don't need anymore. So now I can say, oh, how was it? It was 4. So I can say it's from 4 to 4. So now I only display cluster 4. Aha, now I only also see that there's a CD86 piece in here. So how big can it be? It's not too big, so maybe let's go for 500. Let's see if this is going to become too small. Well, it's not too small, but it's not. These are actually not CD4 positive, so I need to drill further in. So I split again, number 6. I want the CD86, so I'm just going on until I get them. Here they are. So now I didn't get all the CD86, so maybe I want to go on a little more, but I really don't know if it's worth it. So let's just try to have a smaller number. Yeah, no, this was too small. So I don't want to do that, so now I can say, go back. This was too small. So 500 is probably better. Yeah, that's better, but I still didn't get the CD86, so I go on. Still not. Still not. I go on. Oh, and now it rejects so I got a number 19. So I need to say it's number 18 that I want to split. And 21, yeah. So it seems that it's hard to get at this other CD86 piece, but we just go on. There it was. So now I'm happy. I've done some clustering, and I was told by the paper that CD86 was important. So now I've drilled into CD86. So I want to see if the statement from the paper that CD86 positive, CD4 positive cells distinguish between the different groups. So now I'm going to pause the video while I make a UMAP, because UMAP, that's not me, and it takes time. So after a minute's processing time. The UMAP is here. And we see that there's a lot of orange stuff which we haven't drilled into, and then we have these T cells that we did drill into. And we were looking at quite small populations. What I'm going to do next is to save the cluster assignments that I have here. So I'm making a subfolder called labels, and then I'm going to augment the FCS files with the labels I've made. So yeah, that's what I'm going to do. So I'm going to make a new FCS file with the labels that I made. And I need to write the timing information on top. And here, timing is just for you to compare how long does this. So what I'm doing here is I'm reading in the FCS files again, because for the clustering I had arcsine H transformed, and now I want to have the raw numbers, and it's those raw numbers I want to augment with the labels, and only for the sample of cells that I've been clustering. So I loaded in those this sample again, and now I add file ID and label to this, and I just have to learn that the line magic goes first. So this was the first step in doing a longitudinal study. So I'm going to stop this video here, and then I will come back immediately in a new video where I use the cluster assignment that I made here for a sample to extract clusters for all files. So instead of clustering every file and constructing metaclusters, I'm constructing one clustering for a subsample across all the files, and then I'm going to extend that clustering from this subsample to every single file.